Good morning, good morning, good morning, everyone. Hope all is well. We got a few people still trying to connect, so we'll just give them a few seconds. All right, good morning, everyone. Looks like everybody's good. All right, so let's see, where did we leave off last class? We did 2, 1, started 2, 2. I think, and you guys can correct me if I'm wrong, that we are supposed to start here with or even functions, because we did symmetric to x-axis, y-axis origin. Now we're looking at even functions. All right. So anybody have any general questions or concerns before we go ahead and get rolling? Everybody good? All right, all right. So we're still in 2.2. And like I said, we're starting here at even functions. So if it's an even function, when you plug in negative x, you'll get out the original equation once everything's been simplified. If it's an odd function, when you plug in negative x, you'll get the opposite of what you originally had. So in other words, each one of your signs will be opposite of what you had originally. So that's the definition of odd versus the even function. Okay, so the first exercise, determine whether even, odd, or neither. So once again, to test it, you're going to plug in negative x. Plug in negative x and you get out the original equation, which is simplify. And it's an even function. You plug in negative x, and then after you simplify, each one of your signs are opposite of what you originally had. It is considered odd. So the first equation, or first function, x cubed minus 6x. So I'll plug in negative x. And over here, I was just emphasizing the power process when you apply the power to a negative number. If it's even, if it's an even power and you apply it to a negative, then the result is going to be positive, you know, because -2 times -2 will give you a +1. But if it's odd, when you apply an odd power to a negative, it's going to give you a -1. And so that's why I was emphasizing down here. If it's -1 to the 400th power, because 400 is even, the ultimate result will be +1. But let's say if it's 505, applied to -1, the ultimate result will be -1 because there'll still be a negative left over. So when we look at simplifying this, negative x to the third power will still result in a negative x cubed. And then here we have -6 times negative x, which is +6x. And so if you compare this result to what we had originally, you'll see what I wrote down there in the purple. Since each sign is opposite the original function, it is an odd function. All right. Questions on A before we go to B? All right. So here we have g of x is equal to x to the fourth minus 2x squared. All right. So plug in negative x. Negative x to the fourth is going to be a positive x. And negative x squared will also be a positive x. So neither one of those signs will change anything in the function. Notice we have x to the fourth minus 2x squared. So this function is the same as the original. You're always going to compare it after you simplify as much as possible. You're always going to compare it to what you had originally. It's the same as original, so that means it is even. All right, any questions? All right, one more. Here we have x squared plus 2x plus 1. Plugging in negative x squared is going to be positive x squared. Negative x is just negative x. So if you apply that to 2, that'll be negative 2x. And nothing changes with a positive 1. So we simplified as much as possible compared to what you had originally. Notice it says all signs are not the same. Neither are all signs opposite. So this function is neither even nor odd. All right. Any problems? Any problems? All right, can I scroll up? All right, so the next thing, I think this is the last thing out of this section, is the difference quotient. Now, this is just going to introduce you to it. It'll tell you how to find a difference quotient, but the application of the difference quotient isn't really talked about in this class. That's more so of a calculus thing. And so, but they're introducing it to you now so that when you get to calculus, it would not be the first time that you see it. So f of x minus f of x plus h minus f of x over h is your difference quotient. Something that we'll use to find the slope of the line that's tangent to a curve and all the good stuff like that. So it says if f of x is 2x equal to 2x squared minus x plus 3, find the difference quotient. So first thing, recognize that we have f of x. You know, they give that to you originally. So you have f of x. But now we need an algebraic representation for f of x plus h. So what we need to do is plug in x plus h. into f of x, where we see it at x. So that's what I did right here. All right, so what is this? Let me check. Oh, no problem, no problem. I understand. It's 8 o'clock. I get it, trust me. So we need to expand x plus h squared and then distribute that negative in the following parentheses. So that expansion is right here, x plus h times x plus h. All right. So that's x squared plus 2xh plus h squared. Then you distribute the 2. And also, like I said, distribute that negative to give you minus x minus h. And that 3 is still back there. It's not being affected by anything. But right here would be the result of plugging in x plus h for x and then expanding that out. So give me a chance to write that down. All right, everybody good? So now that we have x plus f of x plus h and f of x, we can go ahead and plug it into the difference quotient formula. So you see here we have f of x plus h. Here we have f of x. And that blue arrow just emphasizing where the minus sign is in the formula in reference to what I plugged in. All right, so we can distribute negative into the following parentheses. And we have this. So now every term that that cancels out, because there will be some terms that cancel out for you. Every term that cancel out, well, let me say it like this. Every term that's left after your cancellation will have h in it. So if you still have a term that does not have h in it after your cancellation, then somewhere you went wrong. So in other words, 2x squared minus 2x squared cancels. X and x cancels. And then 8, oh, not h, but 3 and 3 cancels. And that leaves us with 4xh plus 2h squared minus h over h. And so that's why I wrote in the box, each term left must have h in it still. So any questions so far?
Could you then pull out the h to simplify it further?
Yep, that's the next move.
Okay.
So like your classmate just suggested, that 8 has to go into each term. So that's why I wrote right here that the h is going to go into each term. After that, it has to cancel out because of what happens in calculus. H is actually going to be equal to 0. H is going to go to 0 with your limits. And so you do not want to have 0 in your denominator. So the h, excuse me, has to cancel out into each term. And that's what I did right here. And so that left you with 4x plus 2h minus 1 as your difference quotient. So now if h is 0, that's not a problem. 2 times 0 is just 0. But we had to cancel it out in our denominator. All right. Questions. All right, can I scroll up? Do one more, just a little less work. Just making sure we have the process. All right, so let's find a difference quotient of 3x plus 7. So once again, they give us f of x. They have to, right? And then from there, you go and plug in x plus h in for x. And so that's 3 times x plus h plus 7. Distribute your 3. That's 3x plus 3h plus 7. All right. So now that you have f of x plus h, you can plug it into the formula. And that's what I did right here. 3x plus 3h plus 7 minus 3x plus 7 over h. All right, distribute your negative. All right, so it's 3x plus 3h plus 7 minus 3x minus 7. Cancel out the terms that need to be canceled. So it's 3x and the 7. That leaves you with 3h over h. And h is canceled, and that leaves you with just 3. Any questions? All right, can we go to the next thing? Everybody good? All right, so 2.3 takes us into slopes. So linear function and slope. So when you talk about your slope, we're talking about exactly what it sounds like. It's like the slope of a line, slope of a mountain, slope of your ramp or roof. So you're talking about the incline or the steepness or the slant of a line. So the way we will represent slope is by the letter M. And we'll calculate it by doing y2 minus y1 over x2 minus x1, or we can do y1 minus y2 over x1 minus x2. Doesn't matter which order you do it in, just make sure you stay consistent. What I mean by that, if you use y2 first up top, make sure you use x2 first down bottom. Or if you use y1 first up top, make sure you use x1 first down bottom. Also, the relationship that comes from slope is rise over run. We wouldn't use that until we actually graph though. So we use that when graphing, using our slopes to graph. And then x1, y1, x2, y2 comes from any 2 points on the line. Any 2 points on the line would be considered x1, y1. All right, can I scroll up? All right, so I'm on the first one, I'm going to do both of these just to show you that either way you'll get the same answer. But of course, you only have to do one. But I do want to show you that as long as you stay consistent, you'll get the same answer. And I'll just do that for the first one. Is everybody okay with that first definition? Okay. So find the slope of the line passing through the points -3, -1, and -2, 4. So I always label my points. First one I see, I call point 1, which is x1, y1. Second one I see, I call point 2, which is x2, y2. I think it's always best to go ahead and label which one you're going to call point 1, which one you're going to call point 2. And so over here, I did y2 minus y1 over x2 minus x1. So y2 is 4. I'm going back over here to our labeling. Y2 is 4. Y1 is -1. Make sure you don't lose a negative in your substitution. There's a minus sign in the formula, and you're plugging in -1. So sometimes people lose a negative when they do the calculation. So be careful about that. Then x2 is -2. Y2 is -3. Once again, don't lose that negative. Is everybody okay with the substitution? Negative to a negative turns positive. So that's why I have a circle in both cases. So that leaves us with 4 plus 1, -2 plus 3. That ends up giving us 501, which is just 5. We simplify. So before we look at it, calculating it the other way, any questions on what we just did? All right, any problems, any problems? All right, so here, over here, all I did was do flip it. I did y1 minus y2 over x1 minus x2. So that's -1 minus 4 over -3 minus -2. So this time, notice we get -5 over -1, and that simplifies to +5. So either way, once again, you'll get +5. You just have to stay consistent. Y2 first on top, x2 first down bottom. Or if you do y1 first on top, do y1, x1 first down bottom, and you'll still get the same result. All right, can I scroll up? All right, so let's do it again. This time we have -3, 4, and 2, -2. Once again, I label the first point that I see, 0.1, second one, 0.2. X1, Y1, X2, Y2. Y2 minus Y1 over X2 minus X1. Y2 is -2, Y1 is 4, X2 is 2, X1 is -3. So plug it in, simplify. Got -6 over 5. Notice I'm not converting to decimals, just simplifying your fractions. All right, everybody good? Can I scroll up? So basic behaviors of your slopes. We have 4 basic behaviors of your slope. If following your slope from left to right, it goes up. So notice my line is going up. As you move from left to right, it's going up. Your slope is positive. If moving from left to right, it goes down. Your slope is negative. If it's a horizontal line, your slope is 0. Vertical line, your slope is undefined. Any problems with that? Can I scroll up?
Actually, would you mind waiting a minute if you don't mind?
Sure.
Thank you.
Not a problem. Let me know when you finish.
Thank you so much.
Yeah, not a problem, not a problem. All right, so everybody else good? All right, so the next thing we're doing is graphing using these slopes. That takes us into graphing. So like I mentioned, when we first started talking about slopes, the slope gives you the relationship of rise over run. So that means if you're talking about rise, you're talking about going up or down. Your run means you're going right or left. So what dictates the direction that you would go is whether you have a positive or negative move or positive or negative number in your numerator versus your denominator. Your positive moves are up and right. Negative moves are down and left. All right. So we look at these two right here. If you have a +2 over a +3, that means you go up 2, right 3. But if you have a -10 over 7. Now the whole thing, both numbers aren't negative. The negative only goes to 1. I can scroll up, right? So you just make a decision which one you want to give it to. I always say just go ahead and give it to the numerator, but recognize you have a negative 10 over a positive 7. But if you give it to the denominator, that means you have a positive 10 over a negative 7. Okay. So you just have to make a decision, like I said, which one it goes to, but it's not negative over negative because remember, that's a positive. So the negative doesn't go to both numbers. But if you give it to the top, that means you would go down 10 and then right 7 because it's a negative 10 over a positive 7. Or if you have a positive 10 over negative 7, you would go up 10 and then left 7. All right. So down 10, right 7, or up 10, left 7. And either way, you'll create the same line. So if this is our middle point, if I were to go up 10 and then left, up 10, left 7, it'll put me over there. Or if I went down 10, right 7, it'll put me here, but it still will create the same line. So it doesn't matter which one you do, just have to make sure that you do it correctly. Any questions? Gonna scroll up. So what's going to help us to create or graph using our slopes is the slope intercept form, y equal to mx plus b, wherein what's in front of x is your slope and the other number is your y-intercept, but that's only if you solve the equation for y. If y is on one side by itself, then in a linear equation, the other side simplified is going to be in slope intercept form. Once again, the number that's attached to your x is your slope, and then the other number is your y-intercept. So if I have this equation here, y equal to 2/3 x minus 1, what's in front of x is your slope, or what's attached to x is your slope, that's 2/3. And then the other number, -1, is your y-intercept. Same thing here, -4x plus 3. What's in front of x is your slope, which is -4, and then the other number, 3, is your y-intercept. Once again, that's if you have solved your equation for y. Any questions? All right, can I scroll up? So let's look at graphing y equal to 2/3 x minus 1. So we have 2/3. We already established that 2/3 is my slope and -1 is the y-intercept. So if 2/3 is the slope, that's a +2 over +3. That means I'm going up 2 and then right 3. Both of my numbers are positive. And if -1 is a y-intercept, remember we talked about y-intercepts last class, as a coordinate, that's 0, -1. And so that's always going to be the case for whatever this number is. It is your y-intercept, so the coordinate of that is going to be 0 and that number. So here are your steps. First thing you're going to do is graph the y-intercept. So that's always the first move to make. All right. So go to the origin, go down 1. And then from there, you're going to use the slope to generate another point from the y-intercept. So remember, your slope is not a point. So you don't go to the origin. You go to the y-intercept and you will go up 2 and then right 3. That'll put us right here. Okay. Once again, you generate a point from the y-intercept, not from the origin. So a lot of people make a mistake and they'll go to the origin from with their slope directions. Remember, the slope is not a point, it's a set of directions. You're going to go up 2, right 3, but you're going up 2, right 3 from the y-intercept. Okay. And then from there, you have your line. Yep. This pass over. There we go. Questions on that? Make sure we do it. All right, let's scroll up for another one. So here we have y equal to negative 5x plus 4. Once again, we have our equation in slope intercept form. So that's a good place to be as far as trying to graph using your slopes. Slope is negative 5. Other number, our y-intercept is 4. Is negative 5. So as a fraction, that's 5, negative 5 over 1. So I let my negative stay with 5. So that'll be down 5 and right 1. Negative 5 over positive 1. So that's down 5, right 1. Once again, our y-intercept will always have 0 for x as its coordinates. So first thing you would do is graph your y-intercept. So we will go to the y-axis and go up 4. So that's my blue dot. Then if you go down 5 and right 1, that's my purple dot. And remember, you generate that point from the y-intercept. You don't go to the origin, you go to the y-intercept, go down 5 and right 1. And that's our line. All right, questions on that? Can I scroll up? All right, I thought, give me 1 second, I thought point slope formula was in 2.4. Oh, okay, more slopes, okay. We using 2.4 as well. Okay, here we have your point slope formula. Y minus y1 equal to m times x minus x1. So we'll use this formula to be able to create an equation with given information. So you see our slope is m and then x1, y1 is any point on the line. So notice we're going to be plugging in for x1, m, and y1. And the regular x and y will stay in our equation. Just like this equation right here, notice it still has x and y in it. So they're going to stay in the equation. When we plug in the numbers for those 3 pieces, m, x1, and y1. All right, let's scroll up. So we want to write an equation of the line that passes through -1, 3 with the slope of 4. So they give us a point and they give us a slope. And that's what we need for the point slope formula. So over here in the red, I just went ahead and labeled, according to variables, what each piece was for us. your slope is m. So m is equal to 4. And then our point is x1, y1. Now we plug it into our formula. Y1 is 3, m is 4, x1 is -1. So make sure you don't lose that negative. There's a minus sign in the formula, and you plug it in -1. Negative to negative turns positive. So that'll be 4x plus 4. And then to fully simplify, we'll add 3 to both sides. Y is equal to 4x plus 7.
Where did you get the 2x plus 1 from?
Somebody probably asked me a question from another class.
Oh, okay. Just making sure.
Nope, you're fine. You're fine. All right, any problems with that one before we go to another one? Scroll up, everybody good? All right, so here we have write the equation of a line that passes through 8, 5 with the slope of -1/4. So this time our slope is a fraction. So just like before in the red, I've labeled what piece goes with what. And then we went ahead and do our substitution. So you plug it in 5 for y1, -1/4 for m, and then 8 for x1. So you have to distribute -1/4. -1/4 times x, it's just 1/4 x, -1/4 x. But then -1/4 times -8. Did the calculation right here. So it's just -1/4 times -8/1. You just multiply across. Or if you want to cancel it before you multiply, you could have done that as well. I said cancel before you multiply, you could have done so as well. But just multiplying across, that gives you a positive 8 over +4, which is 2. So that's how we got this 2 right here. And then add 5 to both sides. It's -1/4 x plus 7. All right, everybody good? Scroll up. All right. So that's it for 2.3. That's it for 2.3. Questions. So let's see, how much is 2.4? And then we'll look at 2.5. We can start 2-4. It's still flowing with the same thing that we just ended with in 2-3. Just adding to our concepts of slopes. So we have parallel lines. They're lines that do not touch or cross. And what's important about that, as far as connection to slope, your slopes are the same. All right. So it just means they have the same incline, same slope, same slant. All right. Perpendicular lines, the other set of lines that we'll talk about. They intersect at a 90-degree angle. And that means your slopes are going to be negative reciprocals of each other. So we'll talk about what that means in a second, just give you a chance to write it out. All right. Let me scroll up. So let's make sure we understand and we're okay with the idea of what a negative reciprocal is. So a reciprocal is just flipping your fraction. So if I have 3/4, that's 4/3. The reciprocal of it would be 4/3. Negative 10/7, the reciprocal of that is negative 7/10. And then if I have 5, the reciprocal of that is 1/5. So it's just flipping your fraction. But what we want is the negative reciprocal. So what that means mathematically, you're talking about opposite. So you're just talking about the opposite sign along with flipping it. So you're going to flip it and use the opposite sign. So 3/4, the negative reciprocal, which is the type of slope we're looking for, is going to be negative 4/3. If I have negative 10/7, then the negative reciprocal, the opposite sign, will be 7/10. And then 5, it will be negative 1/5. So we're going to use the opposite sign and flip the fraction when we're talking about perpendicular lines in order to find the negative reciprocal. All right. So just to make sure we're okay, let's say if our original slope is 8/3, a line that's parallel to it will have the slope of 8/3. Remember, it's the same. And then a line that's perpendicular to it, you'll flip that and use the opposite sign. So that's negative 3/8. Then if my slope, let's say if I have a line that has a slope of negative 9/11, a line that's parallel to it will have that same slope of negative 9/11. But then a line that's perpendicular to it will have a slope of positive 11/9. All right. Questions on the relationships of the slope? Slopes of your lines, slopes of your lines. All right, let's scroll up. So it says write the equation of the line passing through -3, 1, and it's parallel to the line 2, y equal to 2x plus 1. All right, so we want a line that's parallel to the one that they give us. They give us this one. So first thing we need to do is get the slope from that line. We have y equal to 2x plus 1. So that's the slope that we have. But the line's gonna, if we're trying to get a line that's parallel to it, then we're going to use the same slope. Remember, the parallel lines have the same slope. So it just so happened that because that's 2, that means the slope that we will use is 2. All right, any problems with that? All right. So now that you have your slope and they gave us the point of -3, 1, we can go ahead and plug that into our point slope formula, y minus y1 equal to m times x minus x1. All right. So 1 for y1, 2 for your slope, -3 for x1, -2, a negative turns positive, so that's x plus 3 in your parentheses. Distribute 2, and that gives you y minus y1 equal to 2x plus 6. And then add 1 to both sides. Y is equal to 2x plus 7. Any problems? Any problems? Hold up, everybody good? Very similar to the last one that we did, but this time it's perpendicular. Write the equation of the line passing through 3, -5, and perpendicular to x plus 4y minus 8 equals 0. Then they tell us to express our equation. Oh, I still have my eraser on. Express the equation in general form. So we'll talk about that when we get there. But we need to first find the slope of this line. Notice it's not written in y equal to mx plus b. So we need to solve our equation for y. So that's what I did here. Add x, subtract x from both sides, and then add 8. And that gives us this 4y equal to -x plus 8. Then divide by 4. And don't forget that 4 has to go into each one of these terms when you simplify. So that's what happens over here. And then simplify. So that gives me -1/4 x plus 2. So I give you a chance to write that down. All right, so now our slope of this equation is -1/4. But remember, we're going to slope that's perpendicular to it. So that means we need to flip it and use the opposite sign. So our new slope is going to be 4. All right, everybody okay? So 4 for our slope, 3, -5 for our points. Plug in your values accordingly. So -5 goes to +5 because of the minus sign. Then we have 4 times x, 4 times 3, which is -12. So we have 4x minus 12, excuse me. And then if I subtract 5 from both sides, that'll give us y equal to 4x minus 17. All right. So now we have y equal to 4x minus 17, but it did ask us to put our answer in general form. And so that's general form right there. That just means all of our terms need to be on one side of the equation. That's your general form. So I just went ahead and subtracted y from both sides. 4x minus y minus 17 equals 0. Questions? Any questions? Yep. So that's it as far as 2.4 is concerned. On type of problems in 2.4. Next class will, begin at 2.5. But before we close out, anybody have any questions? Anybody have anything? Is everybody all right? All right. Well, if you guys are good, I'm good. I think 2 sections. Well, we did 2 and some change coming out. 2.2 is good enough for today. All right. Other than that, I will see you guys next class. Have a great weekend. See you Monday.
Have a great weekend, sir.
Thanks. You do the same.
Have a good
Thank you.
day.
Thanks.
Thank you.
Take care. Thanks. Appreciate it. You do the same.